Okay, so this is what we looked at the other time. We introduced logarithms, but first looked at the last portion of indices. So the most important thing here is understanding the definition of logarithm, and that's what we built on so much in the previous lesson. We're trying to make sense of the definition of logarithm. What is this logarithm? What is a logarithm? We said the logarithm is simply the power. It is an index, you know, it is an index. And we looked at all that in details. Here we said if I have q to the power x equals to p, then x is said to be a logarithm of p. You see, x is said to be a logarithm of p. And here we can say logarithm of p to base q equals to x. Even here we say if we have 10 squared equals to 100, then this 2 here, that 2, which is a power of 10, is said to be a logarithm of 100 to base 10. I think we understood this the other time. We said if you have 3 to the power 4 equals to 81, then this 4 here is said to be a logarithm of 81 to base 3. Even here we said if I have 125 equals 5 power 3, then this 3 is said to be a logarithm of 125 to power, base 5. So these are the things we looked at the other time. Make sense of logarithm. We looked at all that. We came here and defined the symbol. If you write, try to mute yourself, please. We don't want that noise. So we said if you have x equals to log p base q, then this q is said to be the base. X is said to be the logarithm. If you just joined in, please mute yourself so that we don't have that. Mute yourself. Okay, so hello, can you mute yourself? So we said when you have log of 5, we also say that if they have not given you the base, they just write log of 5 like this. When the base has not been indicated, then just know that you're dealing with the decimal base. You're dealing, your logarithm is to base 10. This is what we said here, and you find such questions very often, where instead of writing log base 10 of 5 or log of 5 base 10, they'll simply write log 5. So when the base is not indicated, we said that means that the log you're operating in, the base you're operating in is base 10 or a decimal base, what we call decimal base. Then I gave you an example here. I said, write the following in logarithmic notation. They have given you 2 to the power 3 equals to 8. So when you write this in terms of logarithms, it will be log of 8 base 2 equals to 3. That's what we said. So here, we're simply saying that 2 to the power of 3 should be the same as 8. 3 to the power of 3 is the same as 27. Then here we're saying 8 to the power of p equals to q. That's something like that. That's what we spent our time on the other time in the previous lesson. And I also gave you an example of evaluating. You can say evaluate log 125 base 5. Here we said you prime factorize this, or you say it is the same as x. Then prime factorize your 125, you end up with log of 5 cubed power 125, then you end up simplifying it to this. You let this equals x, that means that 125 or 5 power x is equals to 125. That's from the definition of logarithm. 125 is equal to 5 power x. Then you prime factorize 125, which is the same as this. So since the bases are the same, we now apply the concept of indices to manipulate that further. And we end up with x equals to 3. That means that our log of 125 base 5 is the same as 3. We did several other examples here. We came and looked at quite a number of things. Then in the summary, we looked at the laws of logarithms. Well, we said under the laws of logarithm, if you find log of the base, if the base and the number whose logarithm you're looking for are the same, then you always end up with 1. Log of 10 base 10 is 1. Here we're simply saying 10 is the same as 10 to the power 1. That's what we're saying there. So it is not something very hard. There, that's the first law. And then the second law, we say the power law. If I say log of p power x base q, we can drop this power. We can drop this power this side. We can drop the power. We can drop the power. We can carry this power here and drop it. We're trying to buy time as we wait for your colleagues to log in. So this power can be dropped. It comes this side, you know. It comes that side, and we have that x coming here. Then log of p q. We tried it with this example. When you sign in, when you join, just mute yourself so that you don't make for us. We're saying if you're dealing with log of 100 base 10, how can I apply this law here? This is the same as log of squared base 10. So I can drop the 2. I drop this 2, so it comes here. But then you also know from law number 1 that log of the base is the same as 1. Log of 10 base 10 is 1. Log of 10 base 10 is 1. So mute yourself, please. So we end up with this. We end up with that.
Martin, mute yourself.
Mute yourself, please. So we have something like this. You drop the power, so we have 2 log 10, 10. Log of 10, 10 is the same as 1. Log of the base is the same as 1. We tried the same with this example, and we came up with that. So this is what we looked at the other time. That is the second law, the power law. Then the other law is the law of addition. The law of addition, we can say addition or multiplication, because we're multiplying here, we're adding here. So if I have log of p base a plus log of q base a, the bases are the same. I can simply combine them and say this is the same as log of p times q base a. And the reverse is also true. If I have log of p q base a, I can separate them and say this is the same as log of p base a plus log of q base a. This is the law of addition. You can say addition stroke multiplication, since it works either way. Multiplication. Then we have an example here on that law. I gave you this example. I said express as a single logarithm. So this is separated. It is not a single logarithm. It is we have 2 logarithms here. Log of 3 base 2 plus log of 4 base 2. These are 2 logarithms. You can express them as a single logarithm by bringing them together, and you shall have log of 3 times 4 base 2. You see? Log of 3 times 4 base 2. That's what the law says. When you have independent logarithm like this, you can express them as 1 logarithm, and you end up with this, which gives us that. Then the second one, we said log of 4 base 3, log of 8 base 3. Notice that the bases have to be the same. If the bases are not the same, then the law doesn't apply. So this will give us log of 4 times 3 base 4 times 8 base 3. That's what we looked at the time. Then the law of subtraction. This can be the law of subtraction stroke division, since it applies either way. The law of subtraction stroke division. Now here, when you're dividing, you have log of p divided by q base a. Log of p divided by q base a, this will be the same as log of p base a minus log of q base a. So they can also give you something and they say express as a single logarithm. Let's say they can say express as a single logarithm when you have log of, let's say, 100 base 10. Of course, this one is very obvious. Let's say log of, let me get something that is not very obvious. That one, somebody will just say 2. The answer is 2. If you have log of, let's say, we have something can give us 10, 50. Log of 50 base 10 minus log of, let's say, 5 base 10. They can say express this as a single logarithm, or evaluate, or simplify, anything like this. So we know that when you subtract into logs, we can simply divide these powers here. So we shall have log of 10, log of 50 divided by 5. You see, when you're subtracting, you divide. So divide by 5. So this will give us log of 550 divided by 5 is 10. Log of 10 is 10, which gives us 1. You see? So by you applying the law here, the law of division or subtraction, you end up with this answer there. So that's how we use those laws, and we're going to use them very often. Those laws are used in different ways. In fact, we're going to look at very many things using these laws. So in today's lesson, we're starting from the laws again. The other time, our emphasis was so much on the definition of logarithms. Today, our emphasis is going to be on the laws of logarithms. That's what we're going to look at basically today. But before we proceed, if you have some questions as regards to the definition of logarithms, you can ask, and we polish them up before we proceed. If you still have issues, or from the review, if there's something, like I told you at first, that video is already on my YouTube channel. It is loading. I'm sure by the end of this lesson, it will be there. So let's just prepare. From here, you just go and log in and get the video. So under the laws of logarithms, we looked at the first one. When you're looking for the log of the base is 1. Then log of 1. What's the log of 1? We're saying log of 1 is the log of 1 is 0. The log of 1 is 0. I want to give you a simple illustration there. When you're looking for the log of 1, here, I get a pen. This is the first law. We're saying log of the base is 1. How is it 1? Now let's say if you're looking for the log of 10 base 10. We say this is 1. You're simply asking yourself, to which power should I raise this 10 so that I get 10? We know very well that 10 to power 1 is the same as 10. So therefore, the log of 10 base 10 is the same as 1. That's why we're saying log of the base is always 1. Also, this is one of them. We can use that argument. Also, you can say, we're trying to buy time. We can say log of 5 base 5. This will also be 1, because you'll get 1. For me to get 5, it has to be, which power should I raise 5 to? Which power should I put this 5 to so that I get 5? It is power 1. 5 power 1 is the same as 5. You get it? That's why we say log, if this is the same, then it has to give us 1. 3, you can have as many as you want. As long as the base and the number are the same, you're finding log of the base, it will always give us 1. Because 3 to the power 1 is 3. So log of base is always 1. That's our first law of indices. I mean of logarithms, not indices. Forgive me for confusing the two. Then here, Roman number 1, I'm saying, if you're finding, what about if you're finding log of 1? What is log of 1? Now, how do you find log of 1? Log of 1, what will it be equivalent to? For those with calculators, can you try to get log of 1? What do you get? 1 log of 1 to any base will always be 0. Log of 1 to any base will always be 0. Let's try it here and see. If you're finding, the space is too much. If you're finding log of, let's say, you're finding log of, let me pick the right thing this time. If you're finding log of, logarithm of 1 to base 3, you're simply asking yourself, to which power should I raise 3 so that it becomes 1? To which power should I raise 3 so that I get 1? Of course, you know that any number to power 0 gives us 1. So that means that here we shall have 3 power 0 equals to 1. 3 to power 0 equals 1. So that means that log of 1 base 3 will have to give us 1. Yes, Pius? Pius, your hand is up.
I was asking.
Yes?
I'm just joined, but have you yet sent the notes to the group?
Sorry?
So have you yet sent the notes?
Have I sent the notes to the group?
Have you yet?
Not yet. I've just sent the video. I've sent the video to my YouTube channel, so you can catch up with all this work on the YouTube channel, so that you get the work and the explanation. In case you missed out a concept, you copy and listen to the explanation also. Is that okay? Because now the work here is handwritten. It's not typed. If I'm to send, maybe I can send the questions and the summary of what we looked at, but you may not have these answers in the work that I may send to your group. So I may send only typed outline, the laws, maybe, and some few notes, NBs and all the things, emphasis, but the worked out examples, you may not get them. That's why I say I've sent the work to my YouTube channel, you get it there. Okay. Some other person has a hand up. This is Pius. Okay. This is Asha. Asha, your hand is up. What is it?
I have made a mistake because you have recorded log of 1 to base 3 to 1. It's supposed to be 0.
Yes, thank you for that observation. It's supposed to be 0. That's good. It's supposed to be 0. So let me first, a moment please. Let me finish up something here. Pause. Okay, so I think you've understood this. I can say log of any number. It can even be log of 1 to any base, maybe base 10 will still give you 0, because I should write 10 to the power of 0 to get 1. That's what we're saying there. So whenever you find log of 1 to any base, that's why generalizing it base R. This R is unknown. It can be base 10, it can be base 2, it can be base 100, it can end to any base, always be 0. Any number to power 0 will give us 1 always. I think that's noted. Is that okay? Is this okay that we proceed?
Yes, sir.
Okay.
Yes, sir.
Pius, your hand is still up. Is it? Do you still have a question? Or if you don't have a question, you can lower your hand and proceed. Okay, so we proceed. Let me go to another law. We need to understand these laws because we're going to apply them from now on. In the next 3 or 4 lessons, we're going to be looking at these laws and applying them in different ways. You see this table on the side? It is all about these laws. We're going to apply them there. Now, the other law is the power law. I've just explained that in the introduction, the power law. Let me also give you some simple example on this before we proceed on the power law. Power law will also use it. Now, if they say find the log of, it is basically used in evaluations. They can say find the log of 100 base 10. Now here you're asking yourself, to which power should I raise 10 to get 100? We obviously notice 2. How do you use power law to come up with that 2? We can say this is equivalent to the log. We know that 100 is 10 squared. So we say this is log of 10 squared to base 10. So then I drop these 2, I'll end up with 2 log of 10 base 10. But we already know this from the law that we looked at first. This is the same as log of 10 is the same as 1. So we shall have 2 times 1, and the answer ends up in as 2. So here, that's how we use the power law. They can also say, find the log of maybe cube root. They can say cube root. You can say log of the cube root. This can be cube root of 7.
Excuse me, teacher.
Yes, please.
Where did the 1 come from?
Where did the 1 come from? Okay, let me explain that. Where did the 1 come from? So here, look at this step. I want you to look at this step here. Let me put it again. Look at this one here. We're having 2 log of 10 base 10. This is the same as 2 times log of 10 base 10. What's log of 10 base 10?
1.
What's the log of 10 base 10?
1.
Is 1, isn't it?
1.
Yeah, so that will be the same as 2 times 1. You get it? Because all of this is 1. Is that understood now?
Yes, teacher. Thank you.
Welcome. So that's what we have. I was giving you another example. This is example 1. Example 2, I'm saying if you're given, they're saying log of, let's say, square root of 7 base 7. Now, how do I find this? Because I can't say this is 1 yet, because this is having a square root on it. Now, what I do, I apply my knowledge of indices. I apply my knowledge of indices. You can keep writing. If you have a notebook around you, you can keep writing. Because I'm moving very slowly, so you can catch up with me. This is the same as log. This is the same as log of, what's square root of 7 in terms of indices? This is the same as 7 power a half. Then so?
Yes, sir.
Square root of 7 is the same as that. So this gives me that. Now, the law of indices says, the power law says I can drop this power and write it this side. So this will give me a half log of 7 base 7. So this gives me, we know that log of 7 base 7 is the same as 1 from the first law. So this gives me a half times 1. And the answer becomes a half. You see that? So that's how we apply that law. And we're going to apply this very often in our work. This is to look at logarithms. So that's how we apply it. In general form, that's why we're saying log of p to power q base r. We can simply drop the power and write q log of p base r. And that's what we call the power law. Any question from the power law before we proceed to the next law? You have any? It's okay. All right. Let's move on to the next one. That is the law of addition or multiplication. The law of addition or multiplication. Now here we're saying that log of, we're saying, let me pick the pen. Can use a blue pen this time. We are saying that we are saying that log, if let's say I have log of, can I have log of 12.5, log of 12.5 base 10.
So the screen is messed up. I cannot see.
My screen is messed up?
Yes, I cannot see.
We all have that problem?
No, sir. No.
No, sir.
Now
Maybe
it's okay.
Okay, it's all right. So plus log of 8 base 10. We can use this power law here, I mean this law of addition and multiplication, to simplify this or to evaluate it. They can say evaluate this. They can say evaluate, or they can say simplify. Now, how do I simplify this according to this law? The law says if you add in two logarithms that have been written the same base, they have to be of the same base. You can multiply the numbers whose logarithm you're looking for. This will be the same as log of, this will be the same as log of 12.5 times 8 to the base of 10, something like this. What does this give us? What's the log? What's 12.5 times 8? Using your calculator very fast, you tell us that.
100.
100. So this becomes log of 100 base 10. Now at this point, log of 100 base 10 is the same as 2. Or I can simply say this is the same as log of 10 squared. Since I have the laws at my disposal, I can apply anything. Log of that divided by, base 10 like this. Then I drop the power, this becomes 2 logarithm of, this becomes logarithm of 10 base 10. But logarithm of, base 10, of 10 base 10 is the same as 1, so this becomes 2 times 1. And the answer becomes 2, like that. So I've had something like this at first, this and this at first, but I applied the laws and I come up with the answer as 2. And these are the questions that come. You'll find them in question banks, you'll find them in all past papers, standard past papers. When you check in the questions I put in New Vision every week, you'll check and find that logarithm appears almost in all the papers we said. So this is a very common concept, very popular topic that you need to know, and it's applied even in other topics. Even when you go to A level, when you continue with mathematics, even up to A level, you find the same topic there, logarithms. So we need to give it ample time and understand it very well. Okay, let me give you just another one. Just another example here. So power is off. Yes, hello. Power is off. So, and my battery is a bit weak. So today we're continuing with the lesson, but it may end prematurely. So we need to utilize the little time we have very well. Power is off. So we ought to hurry up and finish up what we intend to cover in this little time that we have. because my battery is not all that very strong. It can't stay for over 30 minutes. So this lesson has less than 30 minutes left. And when we pray that power comes back. If it doesn't, then we shall end wherever we shall have from it. So I gave you that example. Let's move on to the next one. I'm going to be now a bit fast. The next one is the subtraction law or the division law. And we said when you're subtracting two terms, two logarithms. Let me just give you a simple illustration here. When you're subtracting two logarithms, what you do is you simply, when you're subtracting two logarithms, what you do is you simply so let's say you have, let me pick my pen. When you have log of, let's say you have log of, let's say, I can say log of 50, like I gave you the other time, log of 50, base 5, base 10, minus log of 5, base 10. This will be the same as log, since you're subtracting them, this will be the same as log of 50 divided by 5, base 10, something like this. So this, you end up with log of 50 divided by 5 is 10, 10 is 10, and that gives us 1. So you see how we apply the laws of logarithm here, laws of logarithms. So we can, that's how we use the law of division. Also, if they say log of maybe, they can also ask you to separate it. You have log of, let's say, maybe we have 5 times 3 base, we're dividing, not multiplying. So we're dividing, let me just change this. Just cross it out. I said log of, let's say 5 out of 3, base 5, base 2 can be base 5. This will be the same as log of 5 base 5 plus minus log of 3 base 5, like that. So that's how you find that logarithm. That's how you find that. Then the next one, we're now looking at general examples. That summarizes the laws of logarithm. Those are the laws that we're going to look at now from now on up the end of this topic. We're just going to be playing around with those laws. Just going to be playing around with those laws. Now let's try out this example here together and we see what we get. They're saying evaluate Roman number 1.
Excuse me, teacher.
Yes, please. You excused?
On that second example,
Yes, please. We can have this as 1, isn't it?
on the second example,
Yes.
you stop there or you continue?
Yeah, you can. Yeah, you continue here because.
Is it okay to?
Yes.
Is it okay to stop there? Can they mark you?
Here, of course, we'll given more information, but then like this part here, you can go ahead and simplify it further because log of 5 is 1. So this will give us 1 minus log of 3 base 5. Now we don't have any information about this. There's no way you can simplify this further. Maybe if they have given you that value, that's when you proceed and finish up this. But as for now, this is the furthest you can go. Is it okay?
Yes.
Oh, okay. Now this part here, Roman number 1, they're saying log of, they want you to evaluate log of 8 root of 2 base 2. That's what they want us to do. There are two ways we can answer this question. The very first one, we can use the definition of logarithms, and we say let the log of 8 root 2 base 2 be the same as, let's say, x. Let it be x. Now, if it is x, we're simply saying 2 to the power of x is the same as 8 root of 2. So you are simply saying 2, according to the definition of logarithms, 2 to the power of x is equivalent to 8 root of 2, something like this. Then we prime factorize the left-hand side so that we come up with the same base like we have on the left-hand side. We prime factorize the right-hand side. So we know that 8 is the same as 2 to the power 3, and we know that the root of 2 is the same as 2 to the power half. So we shall say 2 to the power of x is equivalent to 2 to the power of 3 times 2 to the power of half. That's what we have on the left-hand side. On the right-hand side. So this becomes 2 to the power of x. According to indices, when you're multiplying two numbers with the same base, you can add their powers. So this becomes 2 to the power of 3 plus a half, like that. Power of 3 plus a half. So from this, we can now say this is 2 to the power of x equals to, like I told you, my power is off here, so I'm depending on my battery, which battery is not very strong. So anytime when it dies out, that's where the lesson will have ended. When it dies out, you can wait for like 2 or 3 minutes for my communication. I'll use the WhatsApp group to communicate, and that will be the end of it. So here we have 2 to the power of, what is 3 plus a half? What does it give you? 3 plus a half? What is called 3 plus a half gives us
3.5.
7 out of 2.
3.5.
3.5.
Isn't it 7 out of 2?
Yeah, also 7 out of 2. So that means that our x in this case is the same as 3.5. Our x is the same as 3.5. So that means that from this statement here, from this, that means that our log of 8 root of 2 base 2 is the same as 3.5. We're simply saying now that you should raise 2 to the power of 3.5 to get 8 root of 2. And if you have your calculator, you can try it out and see. By getting 2 to the power of 3.5 or 3.5, then you also get 8 times root of 2. What do you get? You notice that you get the same results. So that's how you do it. This is the one of the alternatively, or you can decide to use. You can decide to use the power law. You can decide to use the power law. The first one, using the definition of logarithms. We use the definition of logarithms, and he has given us that. Let's also see if the power law will give us the same answer. Power law, if we have logarithm of 8 root of 2 to base 2, we are saying this will be the same as log of 2, this is 2 cubed times 2 to the power half. That's what we have. So this will be the same as log of 2 to the power of 3.5, if you add, of course, from the law of indices to base 2. Then the power law says we have to drop this power this side. So we shall end up with 3.5 log of 2 base 2. But from the first law, we said log of a base is the same as 1. Log of 2 base 2 is the same as 1. So the whole of this is 1. We shall end up with 3.5 times 1, because log 2 base 2 is the same as 1. And therefore, our answer here will be 3.5. That's what we end up with. Any questions from there? Do you have any questions from that? Hello?
Yes.
Yes,
So
please.
please repeat it.
Sorry? Somebody is saying something? Yes, Pius?
Please repeat it again. Please.
I repeat which one? The first method or the second method?
My network was poor, but now I'm back.
The network was poor.
Both.
Okay, maybe what we can do is
Yes.
let's do part B. Roman number 2 we use the same knowledge on Roman number 1. They're the same things. So since the battery is down, we are going to do
Yes.
part B using the same Roman number 2 using the same approach. Okay, Roman number 2, let me just squeeze it here since it's not going to be very long. Let me squeeze it somewhere here. Roman number 2 is saying, I don't know why this is not responding. Like I told you, my battery is down, so anytime from now, we're going to be disconnected. Okay, the space has come. So Roman number 2, they are saying log base 3 of 81. Log base 3 of 81, or log of 81 base 3, either way you say it, it's the same thing. We're saying find the log of, one is also taking long to come. If your background is noisy, try to mute yourself that you don't make a lot of noise. Now we have the pen is taking long to come and yet we don't have time. Log of 81 base 3, you're simply asking yourself, to which power should I raise? Should I raise 3 to get 81? We know that already from the concept of, from what we learned in indices. But now here, we want to see how we can use logarithms, the knowledge of logarithms, to come up with the answer. Somebody's in chat asking for. Well, some of you are busy chatting as they, doing work this way. So the battery is down. But if I can just do this and finish. So we're looking for the log of this pen here is jammed. Look it again. Log of 81 base 3. Base 3. So we said there are two ways for pious you're out. You can now listen and follow this. We said if you have log of you're looking for the log of 81 base 3, how do you use logarithms? We said one of the ways you can say let this is Roman number 2. Let this be equivalent to x. Then here you're simply saying 3 to the power of x is the same as 81. 3 to the power of x is equivalent to 81. So what is, you can see the battery is almost down. So let me finish up this just. When you prime factorize 81, it is the same as 3 to the power of 4. So 3 to the power of x will be the same as 3 to the power of 4. Now from here, you simply say x is equals to 4 using the knowledge of indices. That
Just go.